The design pattern, we're going to talk about the template method pattern. An example we can think of is if we had a logging system, which we had three different kinds of logs. We had the info, trace, and error. All of these logs followed this same sequence. First, we have to announce the severity level. Then we have to append a message to the output. And then if there is a high severity error, we have to trigger an additional alert. If we want to start this off, we might have the info log class. So then we'll have that getting it going. We copy and paste that same implementation into the trace log and change the label to trace. And then we'll copy that implementation into the error log and label that to error. And so we'll add the alert there. We'll have all three classes that are 80% identical. However, later we might actually want to change how some of the messages are saved, or you might want to add some different implementation. But because we had these three different identical classes that were implemented that were following the same sequence, we might end up reaching some issue or bug if all three of these are not coded or changed in the same exact way. The idea is then when we have the problem, when the same algorithm structure appears across multiple classes and there's only minor variations, like we had the log example. In this case, you end up with a lot of duplicated code that's very hard to keep in sync. The naive implementation is just putting everything in one class, and you have all of these conditional branches. When you have this, you're trading all this duplication for fragility. Every time you add in, for example, a new log type, we would have to edit the same class, risking breaking what already works if we put everything in just one class and we just had all these if statements to get to different quote unquote behaviors. The idea is instead of doing that, we want to have an invariant skeleton once, the base way that we're going to go through some behavior. And every variant that we make, we supply only those parts that will differ. Here's the pattern overview for the template method pattern. The gang of four definition is precise. It defines the skeleton of an algorithm in an operation, deferring some steps to subclasses. The template method lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. If we analyze the part where it says without changing the algorithm structure, that's very much the whole point of the template method pattern. The base class owns the sequence. The subclasses themselves own those specific steps. The template method is a behavioral pattern because it's about how those classes and objects cooperate together to get a task done. More specifically, it uses inheritance to distribute responsibilities. We have to think about the template method inverts the control. We think of the callers usually invoking the callees. Here, the base class calls down into the subclass. The base class will say, hey, your notify method at step 1 and your higher tier notify at step 3. The callee will decide which one to do. So for example, we have what we said in the beginning, a logging example. Here, we're implementing it through a log. The structure is really, really clean. All we have is an abstract base class. This defines a public method, the template method, that calls a fixed sequence of steps. Some steps are abstract. Subclasses will all have to implement that. Some are concrete implementation shared by all, and some are optional hooks with no optional default that subclasses may override if they need to. Oh, no. Subclasses extend the base class and override only the steps that they care about. They never override the template method itself. The first one I want to talk about is this log template. This is the abstract base class. Here we're first looking at the log method. And this is the template method. It calls three things in this very specific order. There's the notify, There's the save log, and then there's a higher tier notify method. The sequence is invariant. That means it will never change no matter which concrete subclasses are in play. The save log method is a concrete step implemented right here in this base class. And it shares a DOM list item and appends the message checks to the log panel. Every log type shares this exact implementation, so there's no duplicate. So they all implement this save log. We look at the notify method. The notify method is declared, protected, abstract. This means that every subclass must provide an implementation. This is where each subclass will stamp its severity level. And then we have the higher tier notify. This is declared as a concrete method with an empty body. That's the optional hook. The default behavior is to do nothing. Only subclasses that need escalation behavior are here to implement it or override it. Here we have the info log and trace log. These are just like the simple concrete cases of the implementation. Each of them have the one method class. Info log overwrites the notify to append just info log to the DOM. Trace log overrides the notify method to append trace logged. And that's it. That's the entire class. Both of them inherit the save log method from the base class and chain. And both inherit the empty high tier notify method, which means that for info and trace events, the third step in the algorithm generally, it just does nothing. They don't even have to think about it. This is one of the best things about the template method. Subclasses only see the surface area that they care about. The info log doesn't even have any idea of the high tier notify method unless it decides to look at it or use it. Here's the error log. This is the only subclass that will implement both hooks, the notify method and the high tier notify method. If you think about all the other methods like the log skeleton, the log method skeleton, the save log method, those are getting inherited and unchained. When this is being instantiated, we will have the notify, save log, and then the high tier log. We'll have all three in this implementation. Here we have the Typescript index TypeScript file. And from here, we're going to see that the log helper itself, it's a function that accepts the abstract type log template. And then from there, it's just going to trigger the log method. By typing the parameter as log template, the abstract class, the caller just decouples from all three of those classes. You can pass any subclass and the function just works. This is where we're doing the composition versus inheritance, applying to the interface as opposed to those concrete classes. There's a set interval timer. It simulates an application lifestyle every 2 seconds. On normal iterations, it will create a trace log to mark the start, an info log to record a number being created, and then there's a trace log to mark completion. On iteration 5 specifically, it will just switch to an error log to simulate a failure, and that's what we'll see in the demo. This is our demo here. We're going to go to the template method demo. First, we're going to just see this is the flow. We have the template method. It implements, each one of them implement the notify abstract hook. They all have the save hook, as well as this one is only implemented on the error log. And from here, we're going to look on the right side is we first have this run application. It's going to go through the log helper right here. The log helper is defined as a method that takes the log template, and all it does is just goes through and executes this log with string. Here, it's simulating a method here that just saying application run, but the trace log, info log, we created the node, put the number here, and then the application finished. So it's creating this class as well as creating the string. So when we go through here, you'll see every second it will say trace logged. It will say application run here, and then it will be info logged. It will at the bottom put created node and numbers or string, and it will go say trace logged, application finished. So simply, if we just look through what we had on the trace log, they will just implement the notify, and the notify is creating the trace log here, and then later it should, from the log helper, log the message. And here in the log template, this is the abstract class that every one of these inherit this method here. It goes through, calls the notify, calls the save log. The save log is also the one notified here for all three of these classes. And so do save log here. This one is not implemented. So since we have this as an abstract method, this may or may not be implemented. And we'll see that when we call the log template to log, all of these will have the log here. So we just execute the log message. Since we have this strict invariant way that we go through these, we're able to force this behavior on all of three of these. The only difference is when it gets to 5, then we will actually throw this error log here. And the only difference here is we sent out this message here to the error console. So all three of these have the log. It follows that same way that we will basically log the error here. This one logs the error as well. The only difference is this one will also log this message to the console. So going back to what we had here in terms of the log template, we're doing the log here, going through step by step, but since the error log is the only one that has this high tier notified, then it's able to go not just to these two, but it also go to this bottom one as well. So this is just basically the template method as work. Implemented is doing all three of these, trace, info, but also able to do the error log, adding some additional behavior to this log, to all these logs here. And all of these follow the same skeleton pattern, which is very important to understand. They all do the same order of operations. So through this, we're able to create multiple more classes if we want to with the same behavior and force it to have this specific pattern. And we can know that these two will be inherited on all of these different, for those three implementations. We want to use the template method when we have multiple classes and they all share the same type of skeleton, but they're only differing in 1 or 2 steps. Since we saw the example with the logging, with the info log, trace log, and error log, there's only like a small difference between the 3 concrete implementations. So the idea is you want to enforce this very fixed sequence of operations, but you still want to allow some of those individual steps to vary, such as like the notify method and the high tier notify method as well. If the order matters and it shouldn't change, then the template method will give you that guarantee to follow that pattern. When you're building a framework or library, when users need to plug in like custom behavior without being able to accidentally reorder or skip steps, this is a very good way. It's a good idea to have this kind of implementation as well. It's like enforcing this specific invariant skeleton method of executing in this pattern. So you're forcing no change. The invariant part of the algorithm is substantial enough to be worth centralizing. If the shared code is only one line, it's not really worth a lot of this overhead. Talking about when we don't want to use it, we don't want to use it if, of course, like the classes don't share any shared behavior. This is kind of forcing it into some inheritance hierarchy. Just using the pattern or enforcing the pattern, and it's creating more coupling than it removes. When there's this situation where you need to swap the algorithms at runtime, the template method just locks the variation into the class hierarchy at compiled time. There's no dynamic change. If you need to have that dynamic behavior change, then you probably want to use the strategy pattern that we've talked about before. In this part also depends on inheritance for this template pattern to work. In the situation where we might use a language without inheritance like Go, REST, or many of the functional styles, we would need to work with another way like composition or callbacks instead of the template method, which is strictly more fundamental inheritance pattern. Or if we shouldn't also use this if the skeleton is trivial. If there's only just one step, the template is just seems like it would just be like call this one thing. Just having a simple plain interface is much simpler and clearer. We have some real world analogies to help make this idea more concrete. So first we have cooking recipes. If you think about recipes, they're in this fixed structure, like we have to prep ingredients, we apply heat or cook. The apply heat might mean that it might be through a grill, or you bake it, or you steam it, or you poach it. And then after that, we would have to plate it. So the recipe is the template. The specific cooking technique is the hook you would override. The second one is there are several test frameworks like JUnit, Mocha, PyTest. Each test follows the same skeleton. It's going to set it up, the different fixtures, you run the test body, you tear it down. So the framework owns that skeleton, and all it does is call your code. So you override, there's this method called setup, the test body, and optionally there's like a tear down method. Every time you write a test, you might be going through this template method pattern. And the third one is thinking about like CI/CD pipelines. Every development goes through this checkout, build, and test, deploy. Checkout, build, and test might be identical across all the projects, but if we think about deploy, it might vary. You might have Kubernetes, you might have Docker, you might have serverless, you might have something called bare metal. The pipeline definition is the template, and the deploy is the hook. If we compare this pattern to other related patterns, the first one I want to talk about is the template method versus the strategy pattern. The template method will use inheritance. The variation is baked into the class hierarchy at compile time. The strategy will use composition. So you inject the algorithm as an object at runtime. If the variation is fixed per class type and doesn't need to change, then the template method is simpler. If you need to kind of swap between the behaviors dynamically, like a user picking a payment method, then we want to use strategy. Another one to kind of think of is the template method, and there's modern hooks like the React use effect. There's the Angular life cycle hooks. There's a Vue component life cycle. These are all basically descendants of the template method. The framework owns the skeleton and it calls your callback at the right point. The idea is identical, but the implementation with functions of subclassing, the template method is basically the object orientation ancestor of this hook concept. In summary, there's just these three things to remember. The first one, the base class owns the algorithm skeleton. All the subclasses fill in the blanks. The template method is concrete. The hooks are just abstract or optional. The second one is thinking about abstract methods are mandatory hooks. Empty concrete methods are optional hooks. The distinction matters. So one will enforce the contract, The others just offer an extension point. The third one is the template method will invert the control. The base class is the one that kind of calls the subclasses. We're not thinking about it as the subclasses will call the base class. So when you see an abstract class with a public orchestrating method and the abstract keywords below it, you're looking at this template method. We have the links to the full TypeScript source code. They're in the description below, as well as the GitHub page website that you can access any of the demos. Next up, we're going to be talking about the visitor pattern, which is going to solve a related pattern. We're going to add a behavior to a class hierarchy, but we're not going to be using inheritance. If you enjoy these videos, if you could just like and subscribe if you want to catch the next one, and leave a comment if you've got a real world scenario where you have used the template method. Thanks for watching, and I'll see you in the next one.